Okay, so as we've already looked at, this is where we're going to start looking at our different rules that involve our triangles. And because of the triangle's made up, if we start changing something about it, it's going to have a proportional effect on the rest of it. So if we start making one of the angles a bit bigger, we're going to change some of the other sides by the same proportions. Okay, so all we're going to do is we're going to use that to help us work other things out. Okay, and what we've been able to do is we've been able to kind of formalize the links between different sides and angles. So the first one we'll look at is what we call the sine rule, and that becomes because we take the sines of the angles. And so this is just another one of these functions that we've got on our calculator. You don't have to actually know what to do and how to convert that in. You just have to be able to press the sine button on your calculator, chuck the angle in, and get the angle out that way. Okay, so we've written it here as it appears in the formula sheet, and so what we've got is that you've got side A. If you divide that by the sine of angle A, that should be equal to side B divided by the sine of angle B, which is equal to side C divided by the sine of angle C. Okay, so that's the basic idea behind it, and that's the formula that we are going to use to help us. So, in our first example, we've got two angles, a known side and an unknown side. Okay, so I've got this 9 centimeters on the left and X centimeters on the right. So what I want to be able to do is I want to be able to use this formula to help me. But before I can do that, I need to label my triangle. So there's no clues about what should go where, so it doesn't matter where we could put them. I'm going to start with my angles. So I've got A, B, and C, which makes this side across from angle A, little a, this one here, little b, and this one, little c. And so the first thing I'm going to do is I'm going to write out my formula. So a over sine A equals b over sine B equals c over sine C. And then I'm going to substitute in what I know. Now, when we're using this formula, we'll give you the three fractions in the formula sheet, but when you come to actually work it out, you should only need to use two of them. And so I don't know anything about side A, nor do I want to. I've got no interest in that one, and I don't know anything about the angle at A. So I don't know anything in that first fraction. What that means, though, is it means I should be able to fill in information for the rest of the other two. So the side, little b, is the one I want to know. So it is x over, and then I've got the sine of the angle at B, so I've got the sine of 35, is equal to the side at little c, which is 9, all over sine of the angle, which is 80. And we've deliberately written these both ways just so we can see how they appear. You can write it, when we're writing them down, you can just write it the sine of the number, or you can write it the sine with the number in brackets. It doesn't matter which way you do it, but we've written it here because your calculator will want to put it in brackets. So as soon as your calculator starts to open the brackets, you need to remember you have to close them as well. Okay, so whilst you are welcome to write it in this first way, where it's like the sine of 35, your calculator will default to putting the brackets in. So we need to be aware that we can see them both ways. What I want to know, though, is I want to know this missing side x. And so I'm dividing by the sine of 35 on the left hand side, so it's going to multiply on the right. So I've got 9 divided by sine of 80 multiplied by the sine of 35. Okay, and that's what we're going to ask our calculator, which again is important why we remember to put in the brackets where it wants us to. Depending on your type of calculator, it'll depend on where it wants them. Okay, so we're not going to put them in every possible place, because otherwise we'll just have lots and lots of brackets. And so when we crunch the numbers, we end up getting 5.2, and my units were centimeters, as my missing side. Okay, so looking at another example, what we might want to do here is we might want to use it to help us find a missing angle. So again, what we might want to do is just label our triangle. We can label them whatever we want, A, B, C, like that. So little a the hand over there, a little b, and a little c. So remember, we've got the angles get the capital letters, the sides opposite get the lowercase. So I get a over sine a equals b over sine b equals c over sine c. And we're going to put in what we know. So I've got 20 over the sine of a, because that's the angle I'm looking for this time, I've just got a big dot there, is equal to 25 over the sine of 81. And I don't know anything about the c's, I'm not interested in them this time. Okay, so that's the fraction that I'm going to be getting rid of. Okay, now the thing we've got is kind of doubly difficult, because not only is it stuck in my trig thing, in my sine part, but it's in the bottom of our fraction. So whenever we're seeing this kind of problem and we've got something in the bottom of our fraction, we've got a choice as to how we can do it. So we can either systematically do one thing at a time, or we can use our technique that we would call cross multiplying, which isn't really a thing that you're meant to be doing anymore, but it was how I was taught to do it at school, and it's always worked. So as long as you've got two fractions on either side, all we are looking to do just now is try to start solving this, and we're going to start doing that by getting rid of the fractions. Now we may end up with fractions again, and in fact, because I know where this is going, I know it will have fractions again, but it's just to help us get our head around what it is we're doing. And so what I've got is, on this side I am dividing by the sine of a, so when it moves across to the other side it multiplies, and similarly on the right hand side I'm dividing by the sine of 81, so if I move it over to the left it's going to multiply. And so what we're saying is that that is the same as 20 multiplied by the sine of 81 equal to 25 times the sine of a. Okay, so take a second, make sure you're happy with that. If you're not, then all we can do, and all we would do, is instead we would just take it systematically one thing at a time. Okay, and so what I would have done is I would have multiplied through by the sine of a, so that I would have 20 is equal to 25 over sine of 81 times the sine of a, and we can rearrange it from there. Ultimately, you get to the same point, so it doesn't really matter. What I want though is I want to be able to get a on its own, so my next step is to have the sine of a is equal to 20 times sine of 81 divided by 25. So just a minute ago I had 25 lots of the sine of a, I don't want 25, I just want sine of a. But I don't even want the sine of a, I just want a. And so this is where we're going to have to remember and use our inverse things. Now we don't have to work this out beforehand. Okay, if we remember to buy our scientific calculator, what we can do is we can ask it to find the inverse sine of 20 times sine of 81 over 25. And that's going to give us our most accurate answer. Okay, if we were to do some of the working as we went, then it's going to round for us, and then we're going to miss little bits off, and we don't ever know what it is we're going to end up getting. So we're going to do 20 multiplied by sine of 81 divided by 25, and we're going to take inverse sine, and we get an angle of 52 degrees. And so we can use our sine rule to help us find either a missing side or a missing angle.